Welcome to this e-learning module covering CERN's beam facilities. Before we start with the e-learning, I'd like to briefly explain the basic functions of the player to you. To stop the presentation, click the play button in the lower menu bar. With the previous and next buttons, you can browse through the module. This field offers you the tabs Info, Speaker Text and Search. Use the Info button to get to a specific page. To view the audio as text, you can click the Speaker Text button. The Search button offers you a full text search within the page content and the written audio text. A warm welcome. Depending on the scope of your work at CERN, you will have already attended several face-to-face and/or e-learning safety courses and gained knowledge and CERN expectations with respect to safety. You will have a first impression of CERN's activities carried in its facilities. Now, you may need to enter a CERN beam facility. This safety course addresses those of you who have to make their first access in a CERN beam facility or who are following a refresher safety course. Let me introduce you to Natalie Newman and Mark Trevaux. Like some of you, Natalie will access a CERN beam facility for the first time. As every new person, she has to pay attention to several important safety information and instructions before she can start her work. Working environment, hazards, personal protective equipment, preventative and protective safety systems, what to do in case of emergencies. Her colleague Mark Trevaux has been working at CERN for more than 25 years. Of course, it is always difficult to get used to a new work environment and facilities. To make Natalie's and your start as easy as possible, he would like to share his experiences. During the e-learning module, you will have to answer some questions before proceeding.
It's a pleasure for me to welcome you to CERN's beam facilities and to give you an overview. CERN's beam facilities are our research tools that are housing the particle accelerators, transfer lines, experiments and experimental areas. There are in total approximately 20 beam facilities, hosted in three main complexes: the PS complex, the SPS complex, and the LHC complex. The function of the accelerator is to accelerate particles in the PS tunnel, SPS tunnel, and LHC tunnel. There is also a decelerator to produce antimatter, the AD. All the accelerators together have an overall length of 47 kilometers. In the PS and SPS, particles are accelerated and are made to collide with stationary targets. Secondary beams are then produced and sent in experimental areas. The detectors are located in the experimental areas. And in the LHC, particles are accelerated to high energies and are made to collide with each other in the four main LHC experiments. What happens is observed by detectors that record the results of these collisions. Whereas the experimental areas are situated in big halls above ground, the experimental caverns are underground, where the beams are colliding. The transfer lines connect the machines or an accelerator to its experimental area.
Wait, please. I don't understand properly. Machines?
Machine is another word for the accelerators. Accelerator physicists and engineers at CERN have their own language. Before you enter a beam facility, remember you need first to get the access rights via the Administrative Computing Tool, EDH, and the Impact Working Permit. Furthermore, it's very important that you wear the right PPE. This is what I've learned from day one.
What does PPE mean? Is it a special particle engineer's term again?
No. PPE stands for Personal Protective Equipment. Safety shoes and a safety helmet are the minimum PPE. They are required in all beam facilities. But other personal protective equipment like a self-rescue mask and/or personal hazard monitoring devices may be compulsory in some areas too. as well as a helmet with a lamp. You should always check on the signs in each area. On my first day in the LHC, I got my EDH access rights, put on my safety shoes, my safety helmet with a lamp, as well as a self-rescue mask, and was really curious, and honestly, a little bit nervous too, to start working.
I'm just wondering why different PPE is necessary.
It's simple. You need as many PPEs depending on the hazard you might face. But in every beam facilities, falls, slips and trips, as well as hurting the head, are the most frequent accidents. Therefore, a helmet and safety shoes are the minimum PPEs.
Mark just talked about PPE. Now you can test your knowledge too. Please tick in the box what you think is a PPE.
What about the working environment and in particular the radiation?
In fact, it's quite simple, Natalie. You should be aware that when access will be granted after beam operation, you will enter a radiation area in which ionizing radiation might still be present due to activated material. To record the level of radiation you have been exposed to, you are obliged to wear your CERN personal dosimeter. All contractors should in addition wear the dosimeter provided by their company. Furthermore, in each single area, additional hazards can be present. For example, the various components in the installations need energy to operate, and after operation with beams, they might not be fully switched off. So a common hazard in an accelerator is electricity. Also, to keep the particles in their trajectory, a large number of magnets are needed, although these are generally turned off when you enter. However, magnets might not be totally switched off. That's why magnetic fields can still be present. In this case, a flashing sign will alert you. Any other hazard will be warned by a dedicated safety sign. I remember one particular day in the LHC because I had a remarkable experience. I had to work in the tunnel at one LHC site. To get there, you have to first pass different access systems, already at the site entrance, sometimes at a building, and finally and systematically at the facility's access system. Let's go. You should know that not only in the LHC, in every beam facility, you will find a lot of warning signs. They point out the hazards in each area and enable you to orientate yourself quickly. So please take note of them.
I see. They are extremely helpful. Do you have access any time to the machines?
No, not always. Access to the accelerators, transfer lines, experimental areas and experimental caverns is denied during beam operation in order to protect people from exposure to ionizing radiation produced by the beams. This means you can only access the area when it is safe to do so. To access the LHC tunnel, you have to take the lift to descend 100 meters underground.
100 meters underground? That's pretty far.
Indeed. The LHC tunnel is the deeper one underground, but beam facilities can be at the surface, like in the PS complex. On that working day, I followed all the safety rules and instructions I was given, and felt very safe with my personal protective equipment on. As I was entering the area and walking to my workplace, I heard a siren. At first I flinched and realized there was an emergency. But I had learned the right behavior in the safety courses, and I knew exactly what to do and what to be aware of. Following what I had learned, I started evacuating immediately, following the evacuation signs, checking as well on my way if any warning signs were flashing. I thought it was the beam imminent warning.
What is the beam imminent warning?
It's an alert given either by a siren or by a recorded message. If you hear a beam imminent warning, this means that a beam may be about to be injected. To avoid the injection, you have to immediately break the glass of the nearest emergency stop button, also called an AUG, and then following the evacuation signs. I looked at the evacuation signs to find out where the nearest emergency exit was. In addition, I checked out the walkways which serve as an emergency evacuation route. In an accelerator or inside a transfer line, the walkways are on the side of the beam line, either on one side only or on both sides. In the next minute, I saw how my colleagues were evacuating the facility. During the evacuation, I encouraged myself not to panic, to stay calm, to follow the signs, and join the assembly point. On my way out, I used the green emergency handles to open the doors faster. These handles are for emergency exit only and shouldn't be used to open the doors in any other situation. Actually, this was a real evacuation taking place on that day. I heard a colleague saying that some people had carried out work that had created dust, and the fire detectors triggered the evacuation alarm. We waited at the assembly point at the surface for the fire brigade to arrive as expected by the procedure, and to make their controls. Once this was done, they said that the area was safe again and we could continue our work. We were really reassured and relieved that it wasn't serious. Thanks to the efficient safety system, as well as to the evacuation signalization, we all evacuated safely.
Now, it's your turn. What do you think is the right behavior in an emergency? Please check the boxes.
That was a really unforgettable event, Mark. I see how important it is to wear the right PPE, my personal protective equipment. Summarizing what you told me, a safety helmet and safety shoes are the minimum requirements, as well as the personal dosimeter. In some facilities, additional PPEs and/or personal hazard monitoring devices might be required. Even so, I should be aware of the hazards in the different beam facilities, such as electricity, the presence of magnetic fields, and radiation, of course. But if I follow the warning signs and the access system, I will be safe. These are immensely helpful to enable me to orientate myself in my working environment. And in case of an emergency, I shouldn't panic. Instead, I should be looking at the evacuation signs, checking the warning signals, and following the evacuation routes.
Exactly, Natalie. And remember, this is valid in all CERN beam facilities. And last but not least, anywhere, anytime, in particular in the beam facilities, you shouldn't forget to pay attention to other people too. In our mission, we should spread CERN safety culture as part of a safety system that functions correctly and not to be a part of the danger. Finally, we work with highly complex technology and we want to create a safe working environment in all our facilities. I wish you a great first day and with no incidents like I experienced.
We hope that not only Natalie will have a great first day at CERN's beam facilities, but you too, even if it's not your first time. Please keep a simple rule in mind when working. Don't touch what you don't know, and if something isn't familiar to you, please ask the experts or your supervisor directly. In case of danger, don't forget to call the fire brigade 74444 when you're safe. Report to your supervisor and safety officers any dangerous situation, near miss and incident in order to improve prevention. Thank you for your attention and participation.